Welcome to the channel where we are building a game from scratch using Love2d and Lua. Yesterday we got our entity system randomizing our AI for our enemies there. So some will track my Y position, some will track my X position, and then they each get a random walk speed, and we have our spellcast entities actually colliding with our enemy hitboxes, so we can start to affect our entities here. So, and instead of entities, I call them enemies, like enemy entities. Oh my gosh. But yeah, so I think today we want to figure out, there's a couple of things I want to figure out. There's a bug when I walk off the side of the screen. Sometimes I get stuck in a walking animation. I can't ever like recreate it, but we need to fix that eventually. And then I'm thinking today we might try to get the health on our geckos showing so that we can start adding a decrease in health whenever they come in contact with a spellcast entity, so that we can trigger them to become normal geckos and run away. So let's see if we can get that done. I've got movie tickets for Ghostbusters at 6:15, so I can't program very long today, but we'll see how much we can get done. So let's hit the ground running here. We want to go to our entity class, and we want to give our entity a health. So we'll give it a health. We'll set it equal to whatever we define our health to be. And what that means is in our entity definitions here, once we populate, actually it's in our map declarations, we need to give a health right here for our geckos. So we'll say health gets, let's just say 100. We'll see what that looks like, but now that we've got that, let's see. I don't think that would make us crash. It's just a field that we're not doing anything with. So let's go ahead and try to print up this field for every gecko entity we've got. So we've got a health. So why don't we go ahead and go to the bottom of our file, and let's just see if we can render love.graphics.print over their head, and it just says health. Let's just try to put that at the and you know what, we rendered this. We don't want to put this in our entity class, we want to put it in the entity state. So when they're walking or when they're idling, we'll need to put this print there. So we'll print out health, and we'll give it the floored value of our entities X and Y. So math.floor of our self.entity.y, and then close this. Now let's see if we just see the word health above them when they're in walk state. Let's see. Yeah. I mean, it's awful, right? It's like huge. Let's see if we want a smaller font. We want like as little as possible font, but I think let's just see what numbers look like there. Probably way too many numbers, or way too big of a size. Let's see. Yeah, that's just too big for us to be usefully rendering their health. So let's just make it smaller. Let's go to our dependencies, and this is where we give a font, and we'll say we want to give ourselves a small font. And it's gonna be the same font, just a smaller size. So we're going to go into our fonts folder, into our classic TTF file, and we'll make it a 4, and we'll see what a small font looks like for our entities here. So we'll go love.graphics.setFont, and we'll put our small font in here. Now it should be pixely, but it should be smaller. Oh, it looks so bad. It looks so bad. It looks really bad. There's not much we can do. I mean, we could render like a health bar as opposed to numbers. We could. Maybe. I think we're going to want to do that. So let's go ahead and we're going to set... See, it's just that our health... So, okay, so look what happens when we do a love.graphics.rectangle. And what we're going to do is give it a fill type. And we're going to give it an X position, which is a self.x and a self.y. And then a width and a height. Now the width is going to be, let's give it the width of our tile and a height of only 1. And then let's go ahead and also make it red. So we'll do a love.graphics.set color. And we'll say that the color is going to be 1 on the red channel, 0 on the other colors, 1 on the alpha. Now we love.graphics.rectangle. I thought that would be it. Okay, yeah, it's not a self.x. It's a self.entityx as well as y. Cool. We are changing the color for them, but this is working a lot better than the numbers. And changing the color for us. We only want to do this for if the self.entity.type is equal to an enemy, but right now we only have geckos, so we'll just do that. And then we only want to render the health bar and change the colors if we are that, but we have to set our color to white for ourself. So love.graphics.setColor will get the white enum that we put in there. I don't know if that's the right term for that, but so we've got them only there. Okay, that's really weird. Yeah, we're still red, even though we're setting the color white before we draw our thing here. It's almost like I don't know. It's almost like I feel like if we do we not have a white color in our constants? We do. Let's see if I flush it to white after we're done. Okay, that worked for whatever reason. So we've got little health bars for our geckos when they're in walk state. So all we have to do is see, and then so okay. What I don't like about this is that we have to modify this number 16 down to be a smaller and smaller number until they're dead. So I think what we might want to do is normalize a bigger value to 16. Does that make any sense? Like if we have health being 100 and then 100 would be equal to 16. So that would mean, what would that mean? we would divide by 6.25. So let's keep our health at 100. I believe our health is at 100, and what we're gonna do is calculate the width of this as our self.entities.health divided by, not divided by, actually, yeah, divided by 16. No, we want 100 to equal 16. So we would divide by 6.25. So let's try that. Let's see, it should be a bigger bar, or it should be the same size bar if we did it right. Yeah. So if we didn't do this division, we would get a size of 100 width of the health bar, which is wrong, yeah. But we divide it by 6.25 to normalize it to 16, and then we can decrement our health. So if we, for example, just say that our self.health gets equal to our current health minus a small number like 0.05 or something, we should see it decrease over time. It's self.entity.health. So let's see this. That number should be shrinking over time. See, their health bars are getting lower and lower over time. That's looking right. So now we can subtract health based on 100 rather than 16 to at least be able to render their little health bars like that. So I do want to put their little health bars maybe on the top right of them. So instead of putting it at where they are, we want to put it plus a 16 maybe on the X and a -1. So put it on the top right of them, right? Yeah. So we can see which health bar goes to which one. That might be too far away. Yeah, honestly, it kind of looked fine where it was. So, oops. So we'll do that. We'll keep it there right above them. And then instead of always decrementing this health, well, actually, let's test it first. Like, let's say we minus a 0.5. They should drain health fast now. See how fast they're draining health? Boom. And then when it hits 0, we need to flip a little switch. Oh, this is weird. Okay, yeah. Oh, they're growing in the wrong direction. Okay, so we want to do this. We want to limit this. We want to say a math.max. And then we want to put this value and a 0 so that it never returns a... Yeah, not here. Right here. Math.max will return the bigger of two values. So if that number is getting in the negative, it'll just return 0. So let's try that. So now we've got shrinking health bars, regardless of if it comes from a spellcast or not, but then it just shrinks until they're dead. So let's add another, we'll add another field to our entity. You know what? I'm going to say corrupted. I'm going to start corrupted being defaulted to no, so we don't accidentally not render things right. Or so if we start it as corrupted false, then no one's corrupted. But once we go into our map declarations, when we give this, we can say corrupted gets true. And now our geckos are corrupted according to their field. And then what we want to do is swippity swap this Boolean once those entities have 0 health. So we'll go to our entity walk state. We'll say, you know what, if our self dot entities corrupted, then go ahead, subtract their health. For now, when did we have this self collided gets false? Why did we do that? Why did we do that here? Anyways, let's say if we're corrupted, we're going to go ahead and do that. And then what we can do is we can say if the entity's health is smaller than or equal to 0, then we're going to go ahead and become uncorrupted. Okay, and then we want to do something like if our entity dot corrupted is false, so if not enemy corrupted, then we want to change the animations that we're getting. So we'd want to change our dot animations. So we've got a couple of things to choose from here. We could either reinstantiate a new entity exactly where this one is, or we could potentially change the entity's animations to be the new sprite. But the thing with that approach is that our animation is only used in the init of our entity. Is that right? We run create animations. Okay, so maybe what we do is we overwrite this entity's dot animations with its entities create animations with the correct animation. So we have 2 versions of geckos. We've got, if we go into our entity defs, you'll see we've got a gecko and then we've got a gecko C. So for example, I just want to see if we can overwrite our corrupted geckos to become normal geckos in our walk state for our entity. So for right now, we should be able to run without crashing. I think I want to just test something and say self.entity.animations is going to get a self.entity running the create animations function on our entity defs at our key of gecko normal dot animations. Is that right? Because let's see how we define in our map declarations here when we get our animations. Yeah, we say a gecko type dot animations, which we did that like that. So now hopefully as soon as we should be changing the animation to not corrupted anymore, but normal geckos. They would still have the particle system. Yes, they aren't animating, but they do change the skin. So why are they not animating? We do change the animation based on their direction. Oh, this is getting written over and over and over. So if we were to just put it here instead, for example, I think it would stop that. Yes, yes, yes. See, so they still have the particle system, but then they're becoming uncorrupted. So we want to only render, actually, we only want to include their particle system if they're corrupted. So what we can do is, where is our particle system? We go here and we say P system. We can see in our scene, okay, that's for our spellcast entity. We want to see our geckos P system. Spellcast entity renders. There we go. Okay, so if self type is gecko, then this. So I think we want to also say if self.corrupted is false, then go ahead and do this. And is it clear? P system clear? So we'll say if not self-corrupted, then that. Else self.p system clear. Clear. Yeah. Let's hope that clears the particle system when we switch. It doesn't. If not corrupted. Oh, if corrupted. Okay, that's opposite. Method clear. System clear. Clear. What was it called? P system. Let's grep search. P system. It's not clear. There is a release? No, not release. Let's see what it is. Reset, that's what it is, reset. So reset instead here. Okay, well, we have no particle system now. I think our corrupted is getting reset right away. What the heck? What? Oh. Okay, that's weird. We're getting our self-corrupted all screwed up. I gotta leave here in 10 minutes, so hopefully we can figure this out. Our corruption is wrong, so let's go ahead and make sure we're instantiating our correct corrupted gets true here, whereas our entity class should have corrupted false. Okay. So why is it that right here, if we're type gecko, if not corrupted, actually they should be corrupted because we go put in their map declarations, we give it corrupted true for all of our entities in this map. So we should render the particle system here, but I am not seeing it. I see them. That is weird. Maybe we don't do this, and maybe we default things to be corrupted. Let's see if this changes anything. It gives the particle system there, but it still gives the particle system when they're cleared. So let's put this reset back on and see if that changes it. We see a particle system, and then they still have the particle system, so that's not working. So we need to become uncorrupted once we are walking. So we'll go ahead and in our walk state, we just need to clear our corruption. Oh, yeah. Okay, so we're only clearing our corruption upon a health being 0, which, let's see if the particle system goes away by the time we have no health. Let's see. Hey, look at that. It did do that. That's pretty cool. So what we need to do is really, we need to clear that once we're corrupted. Okay, so now we only need to change this only if this happens, which is we lose our health. We're going to change our animation and clear the particle system. So once they lose health, they turn into normal geckos. Now they are doing regular geckos or regular corrupted gecko logic, but we've got them cleared. This is cool. And then if we're not corrupted, we need to update our, where do we process our AI? We've got a process AI for a type gecko. So let's go ahead and say that this is if self.entity.corrupted, then we want to give this logic that we're currently giving. Then we want to say else if self.entity.corrupted is not true. So if not self-entity corrupted, we're going to say go ahead and just set our entity's direction to be up. Okay, so that should have two different types of logic now. One for when they're corrupted, where they chase us, and then when they die, they go up. That's cool. That's cool. Yes, yes, yes. The slow gecko is too cute. That is cool. So now all we have to do is decrease our health, not just over time, but only as our spellcast entity is colliding with it. Let's see if we can do this in 5 minutes. We're going to say, when we go and check our collision to do the knockback, we're going to go into our, what is it? Where's our knockback? See, this is where we can grab search string knockback and find it if we had done that properly, but we didn't. So we've got to suffer. Where did we put it? Is it in our scene? Let's see, a spellcast entity collides. That's what the function is. Spellcast entity collide. Oh lordy. Try it again. Where is it, dude? Where is it? What do we do? Fire spell collides, that's what it is. Okay, so here's what we want to do. We want to deduct our health for our entity. Well, this is in our entity class, so we would want to just say self.health will get equal to a math.max of 0 or whatever our self.health minus, we could probably do twice or more of what we're currently deducting it by in our entity walk state. So when we're doing our health killing here, right here, we could probably do twice or 4 times as much as this. So what we can do is, instead of just decrementing it, let's do a -1. So let's do -3 and see what that gets us. Because they get pulled away from us as we collide, so they're probably colliding more than 1 frame at a time. So let's see what -5 looks like. and we're going to be decrementing that. And then in our walk state, we're actually asking about our health. So let's see. Now they should have health that isn't going down unless we're hitting them. Oh my god, it's so cool. And then we cleanse them. Oh yes, oh yes, oh yes, they both. Oh yes, they both. Oh yes, they both. Reach for the gun. Oh yes, they both. For the gun. Instead of just giving them one direction, let's give them 4 directions here. Oh, we got 2 minutes. We got 2 minutes. We got to go here. What I want to do is, instead of changing their direction once they're uncorrupted, okay, if not corrupted, we're going to get a random value of our, what is it called? Constants. What is it called? We have a directions, possible directions. Possible directions. From our scene, we've got a possible direction, so let's go do a random index of our possible directions from our scene. So we'll go scene view. Check it out. We'll say entity direction gets scene view dot possible directions at index of random. Okay, and we just need to give ourselves a local random that gets a math dot random of 4. No, yeah, 4. 4 indexes of our possible directions, which is a string, and that should change the direction. Let's see if they get cleansed, and then they have a random direction that they clear. Let's see. It's changing every time, every second. We only want to do it once, and then we want to say, let me just do, for right now, well, since we gotta leave, we're just doing a stupid thing here, where we're saying we have to be flipped in order to do it, and we have to be not flipped. So we'll go make sure our entity class has a flip getting false, and then we'll say, hey, self.flipped is false. We should be flipping it only once we cleanse them. Let's see. And we cleanse them, and then he walks off screen. A random direction. We did it, boys. We did it. That, I mean, that's jacked up. When they get inside, it's jacked up, but they've got random stuff. Okay, let's go ahead and commit here. We got to get diff of a bunch of different stuff. We will clean up. Let's leave us a little note here to fix our flipped. So we'll go here and we'll say to do a more elegant flipped in entity, because that was jacked. But then we'll git commit and go see Ghostbusters. We'll git add everything, and we'll say reduce geckos health upon damage and flip to uncorrupted logic. That's huge. We git commit. Thanks for watching, guys. Thankfully I recorded for YouTube. I'll see you guys tomorrow, and we'll get some more stuff done.